Hi guys, Dennis here. This is lesson 12, Gradients, Derivatives, and Differentiation Techniques. This video is brought to you by Ace with Dennis. Now, learning can be smart, not hard. Don't forget to subscribe and press the bell notification button to stop missing out important updates from me. Now, let's start with the lesson with the concept of gradient of a curve. Let's look at this graph. I have a curve here, and the equation of this curve is y equals to x squared. Here is the question. If this is point P, what is the gradient of the curve at point P? Okay, so this question looks simple, but actually it has been extensively discussed, argued by many mathematicians in the past for decades. Right, many mathematicians in the past, they introduced their own way to find the gradients of one point on a curve. Okay, but most of the methods, they didn't actually give a very accurate answer. Okay, until one day, right, Newton actually introduced this concept, okay, to find the gradient of a curve with a very accurate and fast. Okay, a very accurate and fast way to get the gradient of a point on a curve. Okay, so here is what he recommend. First, we need to zoom the point P very big until the curve becomes a straight line. Okay, so now let's zoom this point into very big, right? So this is point P, and the curve becomes a straight line because remember we zoom it very big. Okay, and this straight line is y equals to x squared. Okay, so now we let the coordinates of P as x squared. Okay, because the y is x squared. So this is x and this is x squared. Now we can draw a right angle triangle here. So with this length as delta x, so delta x means a very small change of x. So this point will be x plus delta x. Okay, so now, and this will be x plus delta x squared. So we have a point here. Let's label it as P prime. So the coordinates of P prime will be x plus delta x plus delta x squared. Okay, and this is delta y, which is delta x plus delta x squared minus x squared. So from here, we can get the curve is y equals to x squared. We can get the gradient with the concept what we have learned from coordinates geometry. So m equals the delta y over delta x. It means that the change of y over the change of x. So as we have mentioned just now, right, delta y is x plus delta x squared minus x squared. Therefore, we can define delta y over delta x as limit delta x close to 0, x plus delta x squared minus x squared over delta x. Then we expand the bracket. We get limit of delta x close to 0, x squared plus 2x delta x plus delta x squared minus x squared over delta x. So x squared minus x squared will be 0. Then it will be limit of delta x close to 0, 2x delta x plus delta x squared over delta x. Okay, then we can factorize delta x. So it will be delta x bracket 2x plus delta x over delta x. And we can cancel the delta x. It will be equal limit delta x close to 0, 2x plus delta x. And since delta x is close to 0, so delta y over delta x equals 2x. Hence, we can say that differentiate of x squared over dx equals 2x. So this is the equation of the gradient of a curve. So what we need to do is, let's say I want to get the coordinates, the gradient of a point with the coordinates where the x is 1, then I just substitute x equal to 1 into this equation. I can get the gradient of the point. Okay, now from here, we can make a conclusion that differentiation is the gradient of a point on a curve. So please remember this, because later part, right, when we want to learn further, we need to understand that the differentiation is the gradient of a point on a curve. Okay, and you will see this very often, very frequent, dy over dx. You might wonder why is dy over dx. So dy over dx is known as the derivative of y with respect to x. Now, by applying the method introduced by Isaac Newton, we can find the gradient or differentiate many curves with different equations. In general, if y equals to fx to the power n, dy over dx, we can also rewrite as d over dx bracket fx to the power n, and it is equal n bracket fx to the power n minus 1 f prime x, where f prime x is the differentiation of the function fx. Okay, but you don't have to really memorize this weird formula by heart. Okay, so there is a rule to get this formula, and here is the rule. So I summarize it with BD, P minus 1, and DB. Okay, what does BD means? BD means bring down the power. P minus 1, it is power minus 1. DB, then followed by differentiate the bracket. Okay, so now let's see, right? The first differentiation, which is if y equals to a, so dy over dx will be equals d over dx a, which is equals to 0. Okay, so there is a reason why is this so. Okay, look, think about it. What is the graph of y equals to a constant? So this is a horizontal line. If you still remember what you have learned in coordinates geometry chapter, right? So if y is a constant, it is a horizontal line. So when a line is a horizontal, the gradient is 0. So that's why dy over dx will be 0. Okay, so this is the first formula. Then second, if y equals to x, then dy over dx equals, we can rewrite as d over dx x. Okay, and the answer is equals 1. Okay, so there is an explanation as well. So remember, what is the graph? How does the graph looks like if y equals to x? So it is a linear line, right? So this is y and this is x, and it passes through the origin. It's a straight line. Okay, remember y equals to mx plus c. So the m is the gradient. So for this case, the m is 1. So that's why dy over dx is 1. So this is the second basic formula. Number 3, if y equals to ax, dy over dx can be written as d over dx bracket ax. Now can you guess what is the value? Okay, yes, the answer is a. Why is this so? Remember similar concept with rule number 2, right? So this is a linear line. Remember, is y equals to mx plus c. The gradient m is a. So that's why dy over dx is equals to a. Okay, so this is the third basic formula. Now move on, number 4. If y equals to x to the power n, okay, so we can apply actually the similar approach with the rule that I introduced just now. Okay, so dy over dx can be written as d over dx x to the power n. So we bring down the power minus 1. Okay, we don't have to differentiate the bracket because we don't have the bracket here. So that's why it becomes n x to the power n minus 1. Okay, so this is the fourth basic formula. Number 5, if y equals ax n, right? So it's a similar concept with number 4. So dy over dx can be written as d over dx ax power n. So power bring down power minus 1. Then it becomes power bring down a times the n. So the power minus 1, then x to the power n minus 1. So this is the fifth basic formula. So lastly, number 6, if y equals to bracket ax plus b to the power n, okay, so we can rewrite dy over dx equals d over dx bracket ax plus b to the power n. So now we have bracket here. We can apply the rule mentioned here, right? So power bring down n, right? Then power minus 1. So n minus 1 here. And then differentiate the bracket. So for this case, when I differentiate the bracket ax plus b, when I differentiate ax, I get a. When I differentiate b, a constant, I get 0, because we can go back to rule number 1 and rule number 3. Okay, so this is then can rewrite it becomes a n bracket ax plus b to the power n minus 1. All right, so this is rule number 6, basic formula. When the equation of the curve gets complicated, there are many steps that we need to do, but ultimately they can be simplified into 5 rules of differentiation. Here are the rules. Rule number 1, constant rule. If d over dx kfx, where k is a constant, we can actually bring out the k, and it will be equal k d over dx fx. Okay, in other words, we can bring out the k outside, okay, so that it won't influence the differentiation. So this is the first rule of differentiation. Rule number 2, addition or subtraction rule. So if I want to differentiate two functions fx and gx where they are plus or minus each other, so we can actually split them up and differentiate them separately, which becomes d over dx fx plus minus d over dx gx. So this is rule number 2. Rule number 3 is called the chain rule. So if I have dy over dx and they actually dependent on another variable, for example, let's say u, then dy over dx can be written as dy over du times du over dx. So how to make sure your chain rule is correct? You just need to check, right? Dy, it will start with dy, so this is dy, and end with dx. So this will be dx, and this must be the same. So du and du. Okay, so this is the chain rule. Next, rule number 4, it is called product rule. So if two functions multiply together, let's say uv, so the differentiation of uv in terms of x will be equals u dv over dx plus v du over dx. So this is the product rule. Please remember this formula. Similarly, we go to rule number 5, which is called quotient rule. So quotient rule involves two functions where one function is divided by another function. So u divided by u over v. So differentiation of u over v in terms of x, the formula will be equals v du over dx minus u dv over dx over v squared. So please memorize this formula as well. Okay, so you don't have to memorize the formula by heart, but when you continue to practice more, then this formula will be very familiar to you. Now, let's apply basic differentiation, which is rule number 1 and rule number 2, into exam questions. Here's example. Differentiate each of the following with respect to x. A, 2x to the power 4 minus 5 third x plus 3 over x squared minus 7. B, cube root of 2 minus 5x cubed. here is the solution. For A, differentiation of this whole expression, right? So the first step, what you need to do is you put them into indices form, where it will become 2x to the power 4 minus 5x to the power of half plus 3x to the power of negative 2 minus 7. Then we can apply the rule number 1. So 2x to the power 4, it will become 8x cubed. So how we get the 8x cubed? So we just take the power, bring down, multiply with the 2, so then it becomes 8. Then power minus 1, then it becomes 3. Okay, so then differentiation of 2x to the power 4, it becomes 8x cubed. Then the next one, minus 5 over 2 x to the power of negative half. Then how we get this term? So what you need to do the same thing, right? The power is half, so multiply with the negative 5 here. That's where we get negative 5 over 2. After that, the power minus 1. So half minus 1, I get negative half. That's how I get the second term. Now, can you try to do the third term? 3x to the power of negative 2. Okay, so again, bring another power. The 3 times negative 2, I get negative 6. Then power minus 1. So I will get negative 3. So then it becomes negative 6x to the power of negative 3. Next one is a constant, minus 7. So differentiation of a constant, we will get 0. Okay, so then from here, I put the answer into the root and the fraction form. Okay, so at the end, the answer becomes 8x cubed minus 5 over 2 sub x minus 6 over x cubed. Okay, now move on to B, right? Differentiation of cube root of 2 minus 5x cubed. So similar with A, we have to put it into indices form, right? Cube root becomes power 1 over 3. Okay, and then repeat the similar process, bring down the power. For this case, the power is 1 over 3. Okay, then I can copy the bracket, but the power also minus 1. So the bracket is 2 minus 5x cubed, then 1/3 minus 1. After that, I have to do one more thing, which is to differentiate inside the bracket. Okay, so I differentiate 2, I get 0. So I don't write here. Then I want to differentiate minus 5x cubed. So do the same thing, 3 bring down, so times with minus 5. Okay, and then the power minus 1 becomes 3 minus 1. Alright, so once I finish this step, then the next step is very simple, just simplify it. So I will get negative 5 times 3 divided by 3. So 5 times 3 divided by 3. Okay, and then the bracket, right? 2 minus 5x cubed, power is 1/3 minus 1, which gives us negative 2/3. Okay, and one more is this x cubed minus 1, I get x squared. Alright, so now the next step, right? 3. So I'll get minus negative 5x squared over 3 cube root of 2 minus 5x cubed squared. So this is the answer for B. Now it is your turn to try this example yourself. Differentiate each of the following with respect to x. A. 3x minus 5 over 2x squared. B. 12 over 3 minus 2x to the power of 3. You can pause the video and try to do it yourself. Alright, so here is the solution. For A, differentiate 3x minus 5 over 2x squared in terms of x. So here is what we do. So we don't have to apply the product rule because we can actually split them up, right, into two different terms. Because you look at the numerator, the denominator, right? There's only one term at the denominator, so we can actually split this whole fraction into two different fractions, which becomes 3x over 2x squared minus 5 over 2x squared. Then from here, we can simplify and put into indices form. So it will become 3 over 2x to the power of negative 1 minus 5 over 2x to the power of negative 2. So now you can apply the rule number 1 and the rule number 2. Okay, so I bring down the power negative 1 to 3 over 2 and power minus 1. Okay, similarly for second term, right, bring down the power, multiply with 5 over 2 and power minus 1. Okay, so this is what I get. So 3 over 2 times negative 1, power minus 1. 5 over 2 times negative 2, so power minus 1, negative 2 minus 1, I get negative 3. Right, then I can just simplify, it become negative 3 over 2x squared plus 5 over 2x cubed. So this is the answer for A. For B, so again, we don't have to apply the quotient rule here. We can actually rewrite d over dx 12 over 3 minus 2x cubed, which becomes, right, put it into the indices form. It is 12 times 3 minus 2x to the power of negative 3. Then I can apply the rule, right? So power bring down 12 times negative 3. Then copy the bracket, 3 minus 2x, and then power minus 1, negative 3 minus 1. After that, differentiate the bracket. So we have 3, differentiate 3, I get 0. Differentiate negative 2x, I get negative 2. Okay, then after that, I can simplify this expression, which becomes 72, okay, times 3 minus 3 minus 2x to the power of negative 4. Okay, put it back into the fraction form, it becomes 72 over 3 minus 2x to the power of 4. So this is the answer for B. Do you get it correctly? Now, let's learn how to apply product rule. Let's look at this example. Given that y equals to x bracket 2x squared minus 3 to the power of 4, find dy over dx. Here is the solution. So recap the product rule, which is d over dx uv equals u dv over dx plus v du over dv dx. So look at this formula. We can see that there are two functions multiplied together, which is the u and the v. So what you need to do is, when you look at the equation, you need to know where is the u and where is the v. So for our case, y equals to x bracket 2x squared minus 3 to the power of 4. Our u is x. Hence, du over dx equals 1. And our v is 2x squared minus 3 to the power of 4. Hence, when you differentiate it, so power bring down, which becomes 4. Copy the bracket, power minus 1. So 4 minus 1 becomes 3. And then differentiate the bracket. So we differentiate 2x squared, we get 4x. We differentiate minus 3, we get 0. Then we simplify, and we get 16x bracket 2x squared minus 3 cubed. Now we can apply product rule here. dy over dx equals u dv over dx plus v du over dx. Substitute everything inside. So u is x, dv over dx is 4 times 2x squared minus 3 power 3 times 4x plus 2x squared minus 3 to the power of 4 times 1. Simplify, we get this, and eventually it is 2x squared minus 3 cubed bracket 16x squared plus 22x squared minus 3. And we still can simplify further. We get 2x squared minus 3 cubed times 18x squared minus 3. So factorize 3 and we get 3 times 2x squared minus 3 cubed, 6x squared minus 1. Now, you can try this example yourself. Differentiate the following with respect to x. A, 2x minus 3 squared times 7 minus 3x squared cubed. B, x squared square root of x plus 3. You can pause the video and try to solve yourself. Okay, here is the solution. For A, let's identify the u. So the u will be 2x minus 3 squared. And the v, the du over dx will be 2 times 2x minus 3 times 2. And we get 4 times 2x minus 3. For v, it is 7 minus 3x squared cubed. Differentiate it, dv over dx equals power bring down 3, copy the bracket, 7 minus 3x squared, power minus 1, then we get a square. Differentiate the bracket, we differentiate 7, we get 0. We differentiate minus 3x squared, we get negative 6x. Simplify, we get negative 18x times 7 minus 3x squared squared. Now put everything together. So d over dx, 2x minus 3 squared times 7 minus 3x squared cubed equals u dv over dx plus v du over dx. And we get 2x minus 3 squared times negative 18x times 7 minus 3x squared plus 7 minus 3x squared cubed times 4 times 2x minus 3. Then we can simplify. This is what we get. Simplify further, factorize all the common factors, and then we simplify the square bracket. And finally, this is our answer. 2 times 2x minus 3 times 7 minus 3x squared times negative 24x squared plus 27x plus 14. This is solution B. First, identify the u is x squared. Hence, du over dx is 2x. V is x plus 2 to the power of half. We remember we will put it into the indices form. And dv over dx equals power bring down half. Copy the bracket, x plus 2 power minus 1. Hence, half minus 1 we get negative half. And differentiate the bracket. We differentiate x, we get 1. We differentiate 2, we get 0. Then we simplify further, it becomes 1 over 2 bracket x plus 2 to the power of half. Hence, differentiate of x squared, square root of x plus 2 in terms of x is u times dv over dx plus v du over dx. Just put all the information inside. We get x squared times 1 over 2 bracket x plus 2 to the power of half plus x plus 2 to the power of half times 2x. Now we simplify, we get this. Okay, then we combine the two fractions together into one fraction. Simplify further, and we get the final answer is x bracket 5x plus 8 over 2 square root of x plus 2. Next, let's learn how to apply Quotient Rule. Here is an example. Given that fx equals x squared plus 3 over square root of 4x minus 1, find f prime x. Here is the solution. Recap the Quotient Rule, which is d over dx u over v equals v du over dx minus u dv over dx over v squared. Notice that how Quotient Rule looks like. So we have two functions, u divided by v. So when you want to apply this rule, you need to first look at the equation that they have two functions. One is at the top, one is at the bottom. So you know that the u is x squared plus 3. Hence, du over dx equals 2x. And the v will be 4x minus 1 to the power of half. Hence, dv over dx equals, so power bring down, which is half. Copy the bracket, 4x minus 1. Power minus 1, so half minus 1, I get negative half here. Then I differentiate the bracket. So differentiate 4x, I get 4. Differentiate negative 1, I get 0. Then we simplify, it becomes 2 over 4x minus 1 to the power of half. Then we can apply quotient rule here. F prime x equals v du over dx minus u dv over dx over v squared. So v is 4x minus 1 to the power half. Du over dx is 2x. Then minus u, which is x squared plus 3. dv over dx is 2 over 4x minus 1 to the power of half over 4x minus 1 squared. Alright, so we combine the fraction together, and eventually this is the answer. Now you can try this example yourself. Differentiate the following with respect to x. A. Square root of 3 minus 2x over x minus 3. B. 5x over 2 square root of 2x squared minus 5. You can pause the video and try to do it yourself. Okay, here's the solution for A. First, we identify the u, which is equals 3 minus 2x to the power half. Then differentiate, so power bring down, half. Then copy the bracket, 3 minus 2x, the power minus 1. So it is half minus 1, you get negative half. Then we differentiate the bracket. So differentiate 3, we get 0. Differentiate negative 2x, we get negative 2. Okay? So simplify, 2 and 2 can cancel. We get negative bracket 3 minus 2x to the power of negative half. Next, the v is x minus 3. Hence, differentiate v in terms of x, we get 1. So now we can start to differentiate this expression in terms of x, which is square root of 3 minus 2x over x minus 3, hence equals v du over dx minus u dv over dx per v squared. So the v is x minus 3, du over dx is negative 1 over 3 minus 2x to the power of half, minus u is 3 minus 2x to the power of half, then dv over dx is 1. So v squared is x minus 3 squared. Then now we combine the two terms at the top. We get 3 minus x minus bracket 3 minus 2x over 3 minus 2x to the power of half over x minus 3 squared. Okay, so make them to have only one single fraction. It is 3 minus x minus 3 plus 2x over 3 minus 2x to the power half times x minus 3 squared. And simplifying, we get x over x minus 3 squared, square root of 3 minus 2x. Here is the solution for B. Okay, so firstly identify the u. Okay, you can take it as 5x, but now I want to do something different. I will just take u as x. So du over dx I get 1. V, you can take it as 2 times 2x squared minus 5. Okay, but now I want to do something different. I will just take it as 2x squared minus 5 to the power half. So when I want to differentiate dv over dx, I will get half. Okay, power bring down is half. Then power copy the bracket, I will get 2x squared minus 5. Then power minus 1. So half minus 1, I get negative half. Then I differentiate the bracket. So differentiate 2x squared, I get 4x. Differentiate minus 5, I get 0. So after that, 2 and 4 you can cancel. Okay, I get 2x. So it becomes 2x over 2x squared minus 5 to the power of half. Okay, now I can combine everything together and do the differentiation. Now you can see the difference. What I do something special here, right, is that the 5 over 2 is actually constant. So I can actually take it out from the differentiation so that this fraction will not affect the differentiation. Okay, then from here apply the quotient rule. So the v is 2x squared minus 5 to the power half. Differentiate the u, I get 1. Then minus the u is x. Differentiate the v, I get 2x over 2x squared minus 5 to the power half over square root of 2x squared minus 5 squared, which is the v. Alright, and then from here, I combine the two terms at the top, right? It becomes 2x squared minus 5 plus 2x squared over 2x squared minus 5 to the power half over 2x squared minus 5. Okay, then combine and make it into one fraction, which is 5 over 2 times 4x squared minus 5 over 2x squared minus 5 to the power 3 over 2. Combine them together, you get 5 bracket 4x squared minus 5 over 2 square root of bracket 2x squared minus 5 cubed. So this is the final answer for B. Now let's discuss second derivative and higher order derivatives concept. We can differentiate a function more than once. If a function is derived once, it is called first derivative. It can be written as dy over dx or f prime x. If a function is derived twice, it is called second derivative. It can be written as d squared y over dx squared or f double prime x. If a function is derived thrice, it is called third derivative. It can be written as d cubed y over dx cubed or f triple prime x, and so on. Okay, but of course, in O Level, most of the time, the highest order that we can go is second derivative. So, all this is called higher order derivative. Now, let's look at this example. Given that fx equals x squared over x plus 2, show that f prime x equals x squared plus 4x over x plus 2 squared. A. Find an expression of f double prime x. Leave your answer in its simplest form. B. Hence, find the range of values of x for which f prime x and f double prime x are both positive. Here's the solution. For the first part, to derive this function, we have to identify that this is a fraction. Hence, we can use quotient rule. So, f prime x will be x plus 2 times 2x minus x squared times 1 over x plus 2 squared. Then we expand the bracket, we get 2x squared plus 4x minus x squared over x plus 2 squared. Simplify, we get x squared plus 4x over x plus 2 squared. So we have proven that this answer is the same as the answer that they want us to show. Next, for B, we want to find the second derivative. So we have to derive second time. Start from the first order, f prime x equals x squared plus 4x over x plus 2 squared. So again, we can apply quotient rule. So f double prime x equals x plus 2 squared times 2x plus 4 minus x squared plus 4 times 2 times x plus 2 times 1 over x plus 2 to the power 4. So we can actually factorize the common factors of 2 and x plus 2. And we left with x plus 2 times x plus 2, okay, minus x squared plus 4x over x plus 2 to the power 4. So we open the bracket and simplify further. We get the answer is 8 bracket x plus 2 over x plus 2 to the power 4. We can still cancel x plus 2 and x plus 2 at the bottom here, so power 4 becomes 3. Therefore, the answer is 8 over x plus 2 cube. Here is the solution for B. So we want f prime x and f double prime x are both positive. Therefore, f prime x is greater than 0. Okay, which means x squared plus 4x over x plus 2 squared is greater than 0, or x squared plus 4x is greater than 0. We factorize, we get x times x plus 4 greater than 0. Now from here, we can solve quadratic inequality. We can draw a number line. This number is negative 4. This number is 0. So to make it greater than 0, it is a smiley face. And we take this region and this region. So from here, x is less than negative 4 or x is greater than 0. Next, we move on to f double prime x greater than 0, which means 8 over x plus 2 cube greater than 0, and x plus 2 must be greater than 0. So x is greater than negative 2. Now we need to combine all the ranges together. So first start with negative 4, and we have this x less than negative 4 here. So that's why we have a white dot arrow pointing to the left. The next one, 0, x is greater than 0. So there's one white dot arrow pointing to the right. So, and here this is negative 2. So x is greater than negative 2. Then we have white dot arrow pointing to the right. And from here, this region is overlapped with 2 arrows. Hence, the final range of x is x greater than 0 for f prime x and f double prime x are both 0, both positive. Alright, now it's your turn to try this similar example yourself. Given that fx equals k over x plus 11x, where k is a constant, show that x squared f double prime x plus x f prime x equals fx. You can pause the video and try to solve it yourself. Here is the solution. So first we'll start with the fx. It is equals kx to the power of negative 1 plus 11x. Then I start to differentiate first derivative. F prime x equals negative kx negative 2 plus 11. And second derivative, f double prime x equals 2kx to the power of negative 3. Then we start from the left hand side for the second equation, x squared f double prime x plus x f prime x. We substitute the f double prime x and f prime x. It becomes x squared bracket 2k over x cubed plus x bracket negative k over x squared plus 11. So we expand, we get 2k over x plus negative k over x plus 11x. So we simplify, it becomes k over x plus 11x, and we find that it is equals to fx. So which is this one. Okay, this one. Therefore, we have shown the equation. Alright, that's all for this video. Thanks for watching. Do you have any questions or thoughts to share? Feel free to write it down in the comment. I would love to hear from you. Do you like this video? Please don't forget to like it and share it with your friends. Until then, I will see you in the next video. Have a great day ahead.